Okay, this is test 3 answers. So find all the zeros. The thing is, we can't factor this function. So, sorry, let's write all the possible zeros using the rational roots theorem. Possible zeros are plus or minus. It's of the form, let me make it more clear. It's of the form P over Q, where P is a factor of the constant term. So that's all plus or minus 1 or plus or minus 2 are factors of the constant term, divided by the Q is the factors of the leading coefficient, which is just 1. So this simply you make combination of the numerator and denominator, it's just plus or minus 1 and plus or minus 2. So let's try which one works. Best is to do it synthetically. So put the coefficients of the polynomial. If there's any degree of x missing, remember to put a 0. It's 1, -2, -2, -3, and -2. Let's try 1. Bring down the 1, multiply. Oops, put on the next column and add. Multiply, multiply. And this is not good. 1 doesn't work. So let's try -1. -1, -3, 3, 1, -1, -4, and -1 doesn't work. Unless I do something wrong. Let's try with 2. So bring down the 1. That's 2, 0, 2 times 0, 0, -2, -4, -7. 2 doesn't work. Did I copy down these code? Oh, see, this is what happens. There's a degree of x to the 5, then x to the 4 is missing. So sorry, people. Late. So it's 1, 0 for the x to the 4, -2, -2, -3, -2. Sorry. Let's go with 1 again. Sorry, 1, 1, -1, -3, -6, so 1 doesn't work. Let's try -1. 1, -1, -1, 1, -1, 1, -1, 1, -2, 2, 0. Yay. 1 works, -1 works, but we should always try it again to see maybe it's a double root. Let's try -1 again. -1, -2, 2, 1, -1, -2, 2, 0. It works. Okay, so from x to the 5, we brought it down to an x to the 4, which brought it down to the x to the 3. Okay, let's try one more. I'm going to try continuing this here. So I'm going to just recopy 1, -2, 1, -2. Let's try 1 again. Maybe, sorry, -1 again. So it's 1, -1, -3, 3, and 1, 4. This is not going to work. Okay, so let's try. We had tried already 1, so it didn't work. So let's try now 2. Bring down the 1, multiply, add, 1, 2, and done. So from x to the 5, we came down to an x to the 4, to the x to the 3, and now it's an x squared. And that's, I'll always know I can do this. So first, let me write 0 equals, what were the factors? We had x minus -1, that's x plus 1. times x plus 1, two of them worked, times x minus 2 times x squared plus 1. Okay, we have the zeros already have negative 1, 2. So the last one, set x squared plus 1 equals 0. So x squared equals negative 1. So x is plus or minus square root of negative 1, which is plus or minus I. So the question is find all the zeros. Zeros are x is negative 1, 2, I, and negative I. And we've said that a polynomial of degree 5 by fundamental theorem of algebra must have exactly 5 zeros, which we have. Okay, says state f of x is a product of linear and quadratic factors. So f of x, this, which we already have above, so I'll write x plus 1 squared times x minus 2 times x squared plus 1. That's it. Okay, it says make a sign chart and sketch. So let's put all the factors down. This is negative fx minus 1 squared. I'm doing it the negative, not separately. I'll do it with the x minus 1 squared. Then we have x squared plus 1 and x plus 2 squared. Well, what are the real zeros? It's 1. X minus 1 is 0 when x is 1. And x squared plus 1 is not 0 for any real number. So we omit that. And x plus 2 is 0 when x is negative 2. Okay. X minus 1 squared is always positive. With a negative in front, so it's always negative. X squared plus 1 we know is always positive. And again, x plus 2 squared, anything squared is always positive. So we have a negative, 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 all three negative. Cool. Let's sketch the graph. So the zeros we can put were negative 2 and 1. Let's find the y-intercept. So that's f of 0. So that's negative outside. 0 minus negative 1 squared is 1 times 1, and 2 squared is 4. So that's at negative 4. Okay, to the right of 1 we are negative. We hit the 1. We have to stay negative, so bounce off. Go through the y-intercept. Hit negative 2 to the left of negative. We are still negative, going to negative infinity. That's it. Number 3. Find a polynomial which satisfies the following condition. Leave answer in factored form with real coefficients. Okay, so the coefficients are real. That means if there are any non-real zeros, they must come in conjugate pairs. So 2 minus I is non-real, so that is a 0. So that means 2 plus I. Because remember, the conjugate of A plus BI, the conjugate of that is A minus BI. So 2 plus I must be also a 0. Okay, so we can start writing, building this. Y equals A always in front. X minus, put the parentheses, 2 minus I. X minus 2 plus I. X equal negative 1 is a 0 of multiplicity 3. So that means negative 1 is a 0 3 times. Negative 1, negative 1, negative 1. So the factor is x minus negative 1, which is x plus 1, but that occurs also 3 times. So let's cube it. And they've told us f of 1 is 2, which we will use to figure out a. But first, remember, you have to clean this up. So you distribute the negative. Distribute the negative. And we use, here we use, this is a plus b, x minus 2 is a, and I is b, times a minus b. And we know a plus b times a minus b is a square. So it's a square minus b square, which is I square. Okay, oops, cubed. But I square is -1. So y equals a times, and expand x square minus x minus 2 squared is x squared minus 2 times x times 2, that is minus 4x, plus 2 squared, which is 4. But I square is -1, so that becomes, with a negative is +1, so that's 5 times x plus 1 cubed. Okay, we just have to figure out a. So we know when x is 1, y is 2, y is 2, when x is 1, so that's 1 minus 4 plus 5, that's 1 plus 1 is 2, 2 cubed is 8. So we get 5 minus 4 is 1 plus 1 is 2. We get 16a equals 2. So a equals 1 over 8. So we can write our final answer, f of x equals 1/8 times x plus 1 squared. And we have to write the form where all the factors with real coefficients. So we can write x plus 1, sorry, to x1 cubed is x squared minus 4x plus. That's straightforward. Okay. Number 4, sketch the graph of y is equal to 1 over x plus 2 plus 1. So we know 1 over x plus 2 plus 1. This is a transformation starting from y is equal to 1 over x. We'll use that. The points we can use is 1, 1, -1, -1. Vertical asymptote x is 0 and horizontal asymptote y is 0. So first we're going to replace x with x plus 2. So that is we shift to the left by 2, sorry. So shift left by 2, because whatever we write, we do the opposite, right? So let's, -1, -1 will become -3, -1. X is equal to 0, the vertical asymptote will now become x is -2. Y is equal to 0 stays y is equal to 0, and 1 comma 1 will become -1 comma, move to the left by 2. And so we have y is equal to 1 over x plus 2. And now we'll replace y with y minus 1. So y minus 1, 1 over x plus 2. So y is equal to 1 over x plus 2 plus 1. Now replacing y with y minus 1, do the opposite. You're adding 1 to all the y's. So you shift up by 1. So -3, 0. Let's plot that point. X is equal to -2 stays. X is equal to -2. That's now our vertical asymptote. Y is equal to 0 will now move because we move up by 1. So at y is equal to 1. It's the horizontal asymptote. And the point -1, 1 will move to the point -1, 2. Moved up by 1. Keep the shape. Keep the shape. So number 5. State f of x in vertex form using completing the square. So let's complete the square. So x squared minus 4x. The coefficient of x squared is 1, so we can just go right ahead. You take half of the coefficient of x, half of -4 is -2, and you square it. So that's 4, and you always add it. Plus 3 was along for the ride. The moment I add 4 on the same side of the equation, I'll subtract. I'll do the opposite of what I did on the same side of the equation. So we've completed the square. So this is x plus half of the coefficient of x, which is -2 squared. 3 minus 4 is negative. And that's simple. So the vertex is at 2, comma -1. That's 2, comma -1. It's the vertex. Okay, and so sketch the graph. So let's find the uh, intercepts. So x-intercept is at y to 0. Add the 1 to the other side. Take the square root. Square root of 1 is 1. So x minus 2 equals plus or minus 1. Okay, so 1 plus 2 is 3. So 3 comma 0 we have, oh, but we shouldn't plot it yet because the domain is for all x less than or equal to h. So our graph only lives to the left of the x coordinate of the vertex, which was at 2. So we can't plot the 3, but negative 1 plus 2 is 1. It's at 1. Let's plot the y-intercept. We plug in x is 0. So that's 4 minus 1, that's at 3. And that should be enough. So 0 comma 3, 1 comma 0, and the vertex was at 2 comma negative 1. Starting from here, you go, and don't forget the arrow up there. Okay, this is, and you should label this as the graph of f of x. Okay, on the same axis, it says sketch the inverse function. So we just flip the x's and y's. So 0, 3 becomes 3, 0. 1, 0 becomes 0, 1. And 2, negative 1 becomes negative 1, 2. And we can have curves. So, okay. Sorry, my mind wandered. I'm sorry. So let's plot this again. So 2, negative 1 becomes negative 1, 2. So that's our kind of vertex, you can see. Okay. 1, 0 will become 0, 1. And 0, 3 will becomes 3, 0. And you can see we have to then start from here. This was the ending, so this will be the beginning. So this will be our beginning, this point here. And we go this way. Sorry about that. My wonder. Okay. And you can see because the arrows should be, it's a reflection over y is equal to x, the line y is equal to x. Okay, done. Find the inverse. So we know of inverse, we have y equals, you have to use the vertex form, or you have to start from the beginning and first convert it to vertex form. So we already have the vertex x minus 2 squared minus 1. So add the 1. So I'm going to solve for x, add 1, take the square root. So x minus 2 was plus or minus the square root of pi plus 1. So x is equal to 2 plus or minus the square root of y plus 1. But now remember the output, the range of the inverse function. So x, let's finish this. So x is the output of the inverse function when the input is y. But we don't write it with a y, so x is this guy. Now the question is, replace the y with x. Should it be 2 plus or minus uh, square root of x plus 1? Well, look at the graph of the range of the inverse. The range of the inverse is the highest is 2 and then it's going below 2. So it has to be 2 minus. Okay. Finally, it says find where the two graphs intersect. They only intersect always, function and its inverse can only intersect on the line y equals x. So you could pick either y, this guy, or 2 minus square root of x plus 1 and set it equal to x, because y should equal x and you solve for x. So let's set x squared minus 4x plus 3 equal to x. It's quadratic. Bring it all to one side. This doesn't factor. Let's use quadratic. So formula negative b, negative b is 5 plus or minus square root of b squared minus 4 times a times c is 12, whole thing over 2a. X equals 5 plus square root of 13 plus or minus square root of 13 over 2. Well, square root of 13 is a little less than square root of 16, which is 4. So let's say it's 3.4, 3.5. So 5 plus 3.5 is 8.5 divided by 2 is more than 4. This point is not to the right of 4 when x is 4. So it has to be 5 minus, again, 5 minus 3.5 is 1.5 divided by 2 is a little more than half, right? Which is what the one we wanted. So the coordinates of the point is the x is 5 minus root 13 over 2 and the y is also 5 minus root 13 over 2 because it's a point on the line y equals x. Okay, state the domain. You know the domain restriction. 3x minus 2x squared has to be greater than or equal to 0. This one here, we can just factor the x out. It's 3 minus 2x. Now, 3 minus 2x squared is a sad parabola because it's minus 2x squared. So it's facing down. The zeros would be, what is this? X is equal to 3 halves and x is equal to 0. We want, where is this guy positive? That is here between 0, including, because we are allowed to be 0. That's it. Number 7, given this point on the graph of f of x, what would be the point on this function? So we know from f of x, we're replacing x with x plus 3. So that means we shift to the left by 3. So this point becomes -1 comma -5. Then we are replacing, so this is the new y is equal to f of x plus 3. Now we're going to replace y with y over 2. So y over 2 equals f of x plus 3. So then the 2 multiplies and comes to the other side. So replacing y with y over 2, you multiply all the y values by 2. So vertically stretch by a factor of 2. So this becomes -10. And then finally, we replace y with y plus 1. We're doing the opposite action. You're subtracting 1 from the y. So you shift down by 1. So we get -1 comma -11. Okay. The last question. State the equation of the polynomial whose graph is shown. And let's go. Y is equal to 8. Right away, I'm going to put 8. Well, let's see. The 0 is 3, so the factor is x minus 3. And remember we talked about it. You can see the function does not change sign as x passes through 3. That means a function can only change sign when its factor changes sign. Okay, when I pass through 3. So the only way x minus 3 does not change sign means it had to be squared or some higher even power. We put the lowest one. Okay. Then we have a 0 at -1. So the factor is x minus -1, which is x plus 1. We change sign there, so the power has to be odd. And then we are at -3, so that should be x plus 3. But here also, as x passes through -3, the y value stayed positive on either side. It did not change sign, so that means the factor did not change sign. And now we know when x is 0, y is -2. So it'll help us figure out a. So that's -5, -2. Um, X is, oh, sorry, putting the y value is getting late. So x is 0, so that is y is -2, so that's 9, that's 1, and that's 9. So that's a 81, a equals -2, so a equals -2 over 81. So final answer, y is -2 over 81 times x minus 3 squared times x plus 1 times x plus 3 squared. Okay, that's it. That is test 3. Not a difficult test in my opinion. All right.